Hi everyone. We're going to graph this greatest integer function of x over 2. These are two different ways to write it. And then we're going to discuss the general way to write something like that. We're also supposed to find the domain, locate any intercepts, and find the range based off the graph. So here it is. Now I want you to make sure you already looked at the parent function. So if you have the parent function, you know it looks something like this. And I'm just going to graph that. And just go down here in quadrant 3 and graph it as well. Because all we have to do is worry about the labeling of the graph. And we want this to go 1, 2, and 3, -1, -2, -3. We want our range to be all integers. So the range is supposed to be all integers, because that's by definition the greatest integer. So the greatest integer is like this. Any number you get when you plug in the value, you have to round down to that integer, to the greatest integer there. So, for example, if you are 17 and a half years old and someone asks you how old you are, you tell them you're 17. You don't tell them usually you're 17 and a half. So that's kind of what this is about. So basically, if we do a table of values, and I'm going to start with 0 and do quadrant 1. So you plug in 0, that maps to 0. So that's what we have. But if you plug in 1/2, you're going to get 1/4. Well, that still maps to 0. And so let's try 1. If you plug in 1, that equals 1/2. Well, 1/2 rounds down to 0, so you're still at 0. Now, if you plug in 2, 2 divided by 2 is 1, and that is an integer, so you can put 1. If you plug in 3, 3 over 2 is 1.5, that rounds down to 1. And if you can see what's happening here, 4 is going to map to 2, 5 still stays at 2. So every time we go up to the next integer, this is what we have. So basically, since this is a 2, what we're going by is 2. So this would be 2, 4, 6, and 8. Because 3 is 1.5. So normally it would go right up in here, but you have to round it down to 1. And on this side, you would have just copy it down, -2, -4, then -6, and so forth, because it rounds down. So if you have -1/2, let's just say we have -1/2. Well, that rounds down. So rounding down means you go to the left. So that rounds down to -1 here. All right, so basically all you do on these is just draw your function. So if I just draw it out, and then you just have to label it correctly. So I'll do that. This is open, open, closed, open, closed. Now, so for this one, if we do the little table of values, we go 0, 1, 2, and 3. These two are going to all map to 0, but once you get to 3, it jumps to 1. So this would be 1, 2, and 3. So basically, by 3s, it's jumping up to the next integer. And on this side, you would write -3, -6, and -9. Now, the domain on these is all real numbers. The range, of course, is all integers. So the range is just integers because you can't have fractions. You only can have integers. That's by definition of the function. And your intercepts, we have a y-intercept at 0, 0, and your x-intercepts are written along this line. So the way you write your x-intercept, or one way to write it, is say x comma 0. You know that that's an x-intercept such that x is in between 0 and 3. But it can't equal 3 here. And the previous one we did, you would write it as x comma 0 such that x is in between x and 2. Including 0 but not 2. Alright, and then we have this one. So what would you do for this one? You just keep graphing the same thing over and over. And I'll do one more. Bring it down here and copy, because the third quadrant's kind of confusing sometimes. Alright, and since we have a 4 here, we're going by 4. So this is 4, 8, 12, 16. This side would be negative 4, negative 8, and then negative 12. And our range here is 1, 2, and 3. If you plug in 8, that maps to 2. So 8 divided by 4, doing the greatest integer, maps to 2. Everything else stays on this line. Domain, again, is all real numbers. The range, again, is all integers. The y-intercept is 0, 0, but our x-intercept, in this case, you write it like this. X is in between, including 0 and not including the 4, because at 4 it bumps up to 1. So you have to include all of these for your x-intercept. So, and then if you do the n, I'm going to just draw it one more time. And draw it in. So then this is just going to be n, and you go by whatever the n is. So if this is n, say this was 2, this would be 2, then you double it. So this is just n plus n, and this would be n plus n plus n, and this would be n plus n plus n plus n, and so forth. So that doesn't really help, but basically your x-intercept would be x comma 0, and then you write such that x is in between 0 and n. Alright, domain and range all stays the same. Alright, that's it. Thank you. Have a nice day. Bye-bye.